In music theory, the circle of fifths is a visual representation of the relationships among the 12 tones of the chromatic scale, their corresponding key signatures, and the associated major and minor keys. More specifically, it is a geometrical representation of relationships among the 12 pitch classes of the chromatic scale in pitch class space. Definition: the term fifth defines an interval or mathematical ratio which is the closest and most consonant non-octave interval. The circle of fifths is a sequence of pitches or key tonalities, represented as a circle, in which the next pitch is found 7 semitones higher than the last. Musicians and composers use the circle of fifths to understand and describe the musical relationships among some selection of those pitches. The circle's design is helpful in composing and harmonizing melodies, building chords, and modulating to different keys within a composition. At the top of the circle, the key of C major has no sharps or flats. Starting from the apex and proceeding clockwise by ascending fifths, the key of G has 1 sharp, the key of D has 2 sharps, and so on. Similarly, proceeding counterclockwise from the apex by descending fifths, the key of F has 1 flat, the key of B flat has 2 flats, and so on. At the bottom of the circle, the sharp and flat keys overlap, showing pairs of enharmonic key signatures. Starting at any pitch, ascending by the interval of an equal-tempered fifth, one passes all 12 tones clockwise. To return to the beginning pitch class, to pass the 12 tones counterclockwise, it is necessary to ascend by perfect fourths, rather than fifths. Play circle of fifths clockwise within 1 octave. Play circle of fifths counterclockwise within 1 octave. Structure and use. Pitches within the chromatic scale are related not only by the number of semitones between them within the chromatic scale, but also related harmonically within the circle of fifths. Moving counterclockwise the direction of the circle of fifths gives the circle of fourths. Typically the circle of fifths is used in the analysis of classical music, whereas the circle of fourths is used in the analysis of jazz music. But this distinction is not exclusive, since fifths and fourths are intervals composed respectively of 7 and 5 semitones. The circumference of a circle of fifths is an interval as large as 7 octaves, while the circumference of a circle of fourths equals only 5 octaves. Diatonic key signatures. The circle is commonly used to represent the relationship between diatonic scales. Here, the letters on the circle are taken to represent the major scale with that note as tonic. The numbers on the inside of the circle show how many sharps or flats the key signature for this scale has. Thus a major scale built on A has 3 sharps in its key signature. The major scale built on F has 1 flat. For minor scales, rotate the letters counterclockwise by 3, so that, e.g., A minor has 0 sharps or flats and E minor has 1 sharp. A way to describe this phenomenon is that, for any major key, e.g., G major, with 1 sharp in its diatonic scale, a scale can be built beginning on the 6th degree containing the same notes. But from E as opposed to G, or G major scale is inharmonic to the E minor scale. When notating the key signatures, the order of sharps that are found at the beginning of the staff line follows the circle of fifths from F through B. The order is F, C, G, D, A, E, B. If there is only 1 sharp, such as in the key of G major, then the 1 sharp is F sharp. If there are 2 sharps, the 2 are F and C, and they appear in that order in the key signature. The order of sharps goes clockwise around the circle of fifths, is 1/2 step above the last sharp. For notating flats, the order is reversed. B, E, A, D, G, C. This order runs counterclockwise along the circle of fifths. In other words, they progress by fourths, following the major keys from the key of F to the key of C flat counterclockwise around the circle of fifths. As each key signature adds a flat, the flats always occur in this order. Flat in the key signature is on the tonic, with only 1 flat. The key of F does not follow this pattern. Modulation and chord progression. Tonal music often modulates by moving between adjacent scales on the circle of fifths. This is because diatonic scales contain 7 pitch classes that are contiguous on the circle of fifths. It follows that diatonic scales a perfect fifth apart share 6 of their 7 notes. Furthermore, the notes not held in common differ by only a semitone. Thus, modulation by perfect fifth can be accomplished in an exceptionally smooth fashion. For example, to move from the C major scale F, C, G, D, A, E, B to the G major scale C, G, D, A, E, B, F sharp, one need only move the C major scales F to F sharp. The circle can be easily used to find out the common chord progression for basic keys. The circle of fifths shows every major key with its corresponding minor key. This can be used as the Vi chord in a progression. The V and IV chord can be found by moving clockwise and counterclockwise from the root chord respectively. The corresponding minor keys of the V and IV are the IE and E respectively. Here are all the chord found for all major keys, in order I, E, I, IV, V, Vi C major, C, D, M, F, G, Am, G major, G, Am, B, M, C, D, M, D major, D, M, F sharp M, G, A, B, M, A major, A, B, M, C sharp M, D, E, F sharp M, E major, E, F sharp M, G sharp M, A, B, C sharp M, B major, B, C sharp M, D sharp M, E, F sharp, G sharp M, F sharp major, F sharp, G sharp M, A sharp M, B, C sharp, D sharp M, C sharp major, C sharp, D sharp M, E sharp M, F sharp, G sharp, A sharp M, A flat major, A flat, B flat M, C M, D flat, E flat, F M, E flat major, E flat, F M, G M, A flat, B flat, C M, B flat major, B flat, C M, D M, E flat, F, G M, F major, F, G M, and B flat, C, D M. In Western tonal music, one also finds chord progressions between chords whose roots are related by perfect fifth. For instance, root progressions such as D, G, C are common. For this reason, the circle of fifths can often be used to represent harmonic distance between chords. According to theorists including Goldman, harmonic function, including functional succession, may be explained by the circle of fifths. In this view, the tonic is considered the end of the line towards which a chord progression derived from the circle of fifths progresses. According to Goldman's harmony in Western music, the IV chord is actually, in the simplest mechanisms of diatonic relationships, at the greatest distance from I. In terms of the descending circle of fifths, it leads away from I, rather than toward it, thus the progression IEVI would feel more final or resolved than IIVI. Goldman concurs with Nates, who argues that the chord on the fourth degree appears long before the chord on 2, and the subsequent final I, in the progression IIVIIOIEVIEVI, and is farther from the tonic there as well. Goldman argues that, historically, the use of the IV chord in harmonic design, and especially in cadences, exhibits some curious features. By and large, one can say that the use of IV in final cadences becomes more common in the 19th century than it was in the 18th. But that it may also be understood as a substitute for the E chord when it precedes V. It may also be quite logically construed as an incomplete E7 chord. The delayed acceptance of the IVI in final cadences is explained, aesthetically, by its lack of closure, caused by its position in the circle of fifths. The earlier use of IVVI is explained by proposing a relation between IV and E, allowing IV to substitute for or serve as E. However, Nates calls this latter argument a narrow escape. Only the theory of a E chord without a root allows Goldman to maintain that the circle of fifths is completely valid from Bach to Wagner, or the entire common practice period. Circle closure in non-equal tuning systems. When an instrument is tuned with the equal temperament system, the width of the fifths is such that the circle closes. This means that ascending by 12 fifths from any pitch, one returns to a tone exactly in the same pitch class as the initial tone, and exactly 7 octaves above it. To obtain such a perfect circle closure, the fifth is slightly flattened with respect to its just intonation. Thus, ascending by justly tuned fifths fails to close the circle by an excess of approximately 23.46 cents, roughly a quarter of a semitone, an interval known as the Pythagorean comma. In Pythagorean tuning, this problem is solved by markedly shortening the width of one of the 12 fifths, which makes it severely dissonant. This anomalous fifth is called wolf fifth, is a humorous metaphor of the unpleasant sound of the note. The quarter-comma mean tone tuning system uses 11 fifths, slightly narrower than the equally tempered fifth, and requires a much wider and even more dissonant wolf fifth to close the circle. More complex tuning systems based on just intonation, such as 5-limit tuning, use at most 8 justly tuned fifths and at least 3 non-just fifths to close the circle. Other tuning systems use up to 53 tones in order to close the circle of fifths. In lay terms, a simple way to see the musical interval known as a fifth is by looking at a piano keyboard, and, starting at any key, counting 7 keys to the right to get to the next note on the circle shown above. 7 half steps. The distance from the first to the 8th key on a piano is a perfect fifth, called perfect, because it is neither major nor minor, but applies to both major and minor scales and chords, and a fifth because though it is a distance of 7 semitones on a keyboard, it is a distance of 5 steps within a major or minor scale. A simple way to hear the relationship between these notes is by playing them on a piano keyboard. When traversing the circle of fifths backwards, the notes will feel as though they fall into each other. This aural relationship is what the mathematics describe. Perfect fifths may be justly tuned or tempered. Two notes whose frequencies differ by a ratio of 3 to 2 make the interval known as a justly tuned perfect fifth. Cascading 12 such fifths does not return to the original pitch class after going round the circle, so the 3 to 2 ratio may be slightly detuned, or tempered. Temperament allows perfect fifths to cycle, and allows pieces to be transposed, or played in any key on a piano or other fixed-pitch instrument without distorting their harmony. The primary tuning system used for Western instruments today, 12-tone equal temperament, uses an irrational multiplier, 21/12, to calculate the frequency difference of a semitone. An equal tempered fifth at a frequency ratio of 27/12 to 1 is approximately 2 cents narrower than a justly tuned fifth at a ratio of 3 to 2. History. In the late 1670s, a treatise called Grammatica was written by the composer and theorist Nikolai Dilisky. Dilisky's Grammatica is a treatise on composition, the first of its kind, which targeted Western-style polyphonic compositions. It taught how to write concerti, polyphonic a cappella, which were normally based on liturgical texts and were created by putting together musical sections that have contrasting rhythm, meters, melodic material and vocal groupings. Dilisky intended his treatise to be a guide to composition but pertaining to the rules of music theory. Within the Grammatica treatise is where the first circle of fifths appeared and was used for students as a composer's tool. Related concepts. Diatonic circle of fifths. The diatonic circle of fifths is the circle of fifths encompassing only members of the diatonic scale. Therefore, it contains a diminished fifth in C major between B and F. C structure implies multiplicity. The circle progression is commonly a circle through the diatonic chords by fifths, including one diminished chord and one progression by diminished fifth. Chromatic circle. The circle of fifths is closely related to the chromatic circle, which also arranges the 12 equal tempered pitch classes in a circular ordering. A key difference between the two circles is that the chromatic circle can be understood as a continuous space where every point on the circle corresponds to a conceivable pitch class, and every conceivable pitch class corresponds to a point on the circle. By contrast, the circle of fifths is fundamentally a discrete structure, and there is no obvious way to assign pitch classes to each of its points. In this sense, the two circles are mathematically quite different. However, the 12 equal tempered pitch classes can be represented by the cyclic group of order 12, or equivalently, the residue class is modulo 12. The group has 4 generators, which can be identified with the ascending and descending semitones and the ascending and descending perfect fifths. The semitonal generator gives rise to the chromatic circle, while the perfect fifth gives rise to the circle of fifths. Relation with chromatic scale. The circle of fifths, or fourths, may be mapped from the chromatic scale by multiplication, and vice versa. To map between the circle of fifths and the chromatic scale, multiply by 7, and for the circle of fourths, multiply by 5. Here is a demonstration of this procedure. Start off with an ordered 12 tuple of integers representing the notes of the chromatic scale. 0 equals C, 2 equals D, 4 equals E, 5 equals F, 7 equals G, 9 equals A, 11 equals B, 1 equals C sharp, 3 equals D sharp, 6 equals F sharp, 8 equals G sharp, 10 equals A sharp. Now multiply the entire 12 tuple by 7, and then apply a modulo 12 reduction to each of the numbers, which is equivalent to which is the circle of fifths. Note that this is inharmonically equivalent to. In harmonics, the bottom keys of the circle of fifths are often written in flats and sharps, as they are easily interchanged using inharmonics. For example, the key of B, with 5 sharps, is inharmonically equivalent to the key of C flat, with 7 flats. But the circle of fifths doesn't stop at 7 sharps or 7 flats. Following the same pattern, one can construct a circle of fifths with all sharp keys, or all flat keys. After C sharp comes the key of G sharp. The 8th sharp is placed on the F sharp to make it F. The key of D sharp, with 9 sharps, has another sharp placed on the C sharp, making it C. The same for key signatures with flats is true. The key of E is equivalent to the key of F flat. The last flat is placed on the B flat, making it B.